I'm Chris Norval, and today, on behalf of my co-authors Richard Cloete and Singh, I'll be presenting our paper, Navigating the Audit Landscape, a framework for developing transparent and auditable XR. So to give a bit of a background, extended reality, or XR, is an umbrella term for augmented, mixed and virtual reality technologies, all of which work to blend the physical and virtual worlds. Broadly speaking, augmented reality involves the real-world environment with superimposed objects or information. Mixed reality involves interactive digital objects within the real world, and virtual reality entails a completely digital environment. And these technologies are growing in popularity, being deployed across a wide range of sectors, including surgical and healthcare, avionics, military, travel, and so on. But the nature of XR also raises some fairly interesting challenges from a transparency and accountability perspective. How do we even begin to foresee and preempt the range of possible ways in which an XR system might be used? How do we make sure that these systems are operating in ways that they should be? And if something does go wrong, how do we disentangle what happened and take steps to prevent it from reoccurring? These questions, while not unique to XR, raise particular challenges in an XR context. This is because these technologies and their outcomes are driven by a tight-knit coupling of both physical and virtual environments. As a consequence, it'll often be impossible for developers to predict the range of contexts and scenarios that their systems might be used in. And with so many degrees of freedom, it can be difficult to put appropriate safeguards in place. Further, these XR systems can be driven by various data sources, sensors, and variables interacting at runtime to drive the functionality of the system. This not only means that the system can be complex and opaque, but there will also be many potential points of failure, including those relating to hardware, software, the physical environment, and human error. And third, when something does go wrong, the physical nature of XR means that it can directly lead to physical harms, in addition to those more traditionally discussed with regard to algorithmic systems. Things can and do go wrong, and this is something we need to be thinking about. So for example, an XR system might provide incorrect instructions to the or information to the operator, causing them to take unsafe actions. Or a digital annotation might distract the user or obscure a potential hazard. In fact, we've already seen countless news articles and reports linking XR applications to damage, injuries, and even death. So in the event that something does go wrong, it'll be important to understand why. This is an example taken from another paper of ours, which summarizes the types of issues and harms that can arise from XR systems. And we used these to argue that more needs to be done to make these technologies auditable. Auditability concerns having the ability to reveal and enable some reconstruction of the system's use, its runtime behavior, and its surrounding contexts. This might include, for example, information about the various technical components involved, about the physical and virtual environments, and the broader contexts of use. In the event that something goes wrong, or if there's simply a need to better understand why an XR system is behaving in the way that it is, audit information can play a vital role in the review, scrutiny, and comprehension of these systems, supporting broader transparency and accountability aims in the process. But what information do we capture and how? In previous work, we demonstrated that capturing technical data can itself introduce its own tensions, and it may not always be possible or necessary to capture everything. And so what might be appropriate for a surgical application, for example, may be entirely different to that within an industrial context. But again, XR systems will often introduce socio-technical concerns above and beyond just technical data capture. And so XR systems will need to be designed, built, and instrumented in such a way that they capture and produce the right information. The right information to enable various stakeholders to review, understand, and scrutinize how these systems are operating in practice. But given that there is no one-size-fits-all approach to auditability, it can be difficult for those building XR systems to know what to record, when and how to process data, where to store it, and why. So to support the auditability of XR, we created a framework to systematically guide developers through the instrumentation process, determining what information is relevant within their particular contexts, and the various considerations and implications of doing so. This helps make information about XR systems more transparent, much like we've seen in other contexts, such as model cards, fact sheets, and data sheets within algorithmic systems. The framework is split into 3 classes, and each of these were derived from and encapsulates our previous findings and those from the literature. The general class helps consider the overall intent of the system to set the broader context for exploring audit concerns. It helps to identify the various stakeholders involved, the risks that might arise as a result of the system, and the resource constraints, be they technical, financial, or other, that will be in place. The capture class helps those using the framework to identify the various data sources available for capture across all relevant components, and to reflect on the various considerations for capturing each of these data sources of interest. These include the granularity and frequency of data capture, the potential impact of data capture on the system itself, the sensitivity of the data, and so on. And the record class concerns the data management and storage of the records produced. It covers aspects such as whether data is stored locally or transferred off device, and the storage, network, and security considerations that each of these may raise. Furthermore, it helps those using the framework to consider whether capturing particular information might raise legal or compliance-related obligations. In all, our framework aims to help systematize the audit process. Naturally, this can be useful for a broad range of stakeholders in understanding the types of data capture and considerations that might be relevant in any given scenario. This will include the operators of these devices, auditors, regulators, and so on. But our main focus with this framework is XR developers, given that they'll often be the ones responsible for instrumenting their systems and implementing audit regimes. And so we wanted to put our framework to the test with 20 expert XR developers to see whether the framework could help them to identify more data sources and more audit considerations with the framework above and beyond their current processes for doing so. And what we found was that it did. Using the framework was statistically linked to identifying more data sources and considerations. The participants also reported that they found the framework to be usable, helpful, and that they would likely use the framework again in the future. In other words, our framework helped support the participants in thinking about auditability and recognizing the importance of their decisions. And finally, during interviews with the participants, we found that the auditability of XR systems doesn't currently seem to receive much consideration, that there was a need for structure and guidance in implementing data capture, and that they appreciated the framework's role in supporting this process. So bringing things together, the auditability of XR is important, and this is an area that warrants attention. XR systems are seeing wider deployments across a range of different use cases and contexts, and the ability to review, scrutinize, and oversee how these systems operate will likely play a key role given the range of risks that these technologies can present. Our framework aims to support XR stakeholders in navigating the audit landscape, in determining the types of data capture that might be appropriate, and the various considerations and tensions that might arise as a result. But more broadly, there are plenty of research opportunities that can help advance this area. For example, different technical tools that can help developers put audit regimes in practice. And this is something we're also thinking about. We'll be at UbiComp later this year to present Droiditor, an open source technical tool to help mobile XR developers implement data capture within their systems. But there's much more that needs to be done, including on aspects such as issues of privacy, surveillance, and the broader risks of audit data, security considerations, data usability, stakeholder engagement, and how approaches to XR auditability can fit within broader audit regimes, to name a few. And so we'd like to encourage the FACT community to think about some of these challenges and to help advance this important, yet currently under-considered topic.